All right, we're broadcasting. I guess you guys are going to hear some singing in the background.
Oh, great.
Hey, Bowen. Bowen. All right, Phil, are you with us?
Yes, I am.
Okay.
Sorry. It was actually me that was out. I realized that I had somehow clicked on an old video.
Oh.
So.
Okay. Yeah, I was like, wait a minute, that's our conversation from. It was like echoing. I was like, that's so weird. Okay. So, you're in the group quiz, Phil?
Yeah.
All right. Island. Okay. So it says we can do the first two on our own. Two. Okay. So it says note, give all your probability answers as decimals. For example, 0.1234. Do not give probability answers as percents. Okay, that makes sense. Human blood can be classified into one of the four basic types, O, A, B, and AB. The proportion of people in the population of the United States with each of these blood types is summarized in the following table. Okay, use this data to answer the following questions. The blood types and proportions given in the table above define a probability distribution.
So I would say yes, because it follows all of the probability rules. It's not greater than 1, it's not less than 1, it all sums up, if you add them all together, it's 1.
Does it? Okay, I haven't tried to add them yet.
Seems that it would be true, at least based on the rules of probability distribution.
Yeah, you're right, it does equal 1. Yeah. So true?
Yeah.
Yeah.
Okay. What is the probability that a randomly selected person in the United States has type O blood round to 2 decimal places? So there's 4 types, right?
Right. So, well, that would be a point.
But it gives the proportion.
41. Well, isn't this when we would do the point? .41 divided by. I want to see that the dice thing again. But we don't. I don't think we just divide it by 4 because it's not.
Okay.
They're not equal parts.
Okay.
But I could be wrong. Let me double check.
Yeah, it's not proportion. It gives us this proportion up here, but is that the probability?
Okay, hold on. I'm just double checking.
That doesn't end up to. Yeah, it does. Never mind. JK.
Okay, we can revise the double decision. We add a column that gives the product and value of the portion of times it occurs. And we add it. Okay, we don't want the mean. Hold on.
So is this the one where we do, here, let me go back to my notes.
I'm thinking this is the one where we add up the do the same example as the as they gave of Columbus, right?
Okay. I'm going to open up my book again.
I'm trying to find where that was. Was that a separate? Was that like an additional? Do you guys remember the Columbus?
Yes, I do. Yeah.
Was that in the reading, or was that one of the other links?
I'm sure it's in the reading. They have the, yeah, let me see. Okay. Oh, yeah, it's at the top. Yeah, it's at the very top. Let's see.
Oh, okay, here it is. Okay. Okay, there are 41 men. What is the probability who would draw the P? So yeah, that one would be then just 1 divided by 4. Right?
Yeah.
That seems too easy though. Hold on.
Yeah, because they give us the proportion, so I don't know if we have to go by that number. I'm sorry, go ahead.
Be the 0.45? I was going to say, wouldn't it just be the 0.45?
That's what I'm thinking, but then I'm like, that's too easy. That's so tricky.
Oh, so I know you would subtract that.
Out of 100.
So it's actually hold on. That then it would have to be 45%. Yeah, you're right. It would have to be. I'm all nervous now because I don't want to.
I know.
So I'm just questioning everything. Hold on. Okay, select the Columbus thing. There were 41 men aboard the ship. The probability the Columbus would draw out the marked P. And to figure out the probability, you would do 1 divided by 41. So in our case, it would be 1 divided by...
What's the answer, 45?
It would have to be 45 because you wouldn't put in any of the other numbers, and you wouldn't... So then, as a percent, that would be 2%. So then as a percent, that number would be...
Or do we have to find out the not, let's see. Yeah, I have like 2.222 if we divide 1 by 0.45.
Round to 2 decimal places. So that's what I got too. So it would be 2. But it would be 2.222. That doesn't seem enough though. If that's the greater.
No. Because it's a big portion of it. It should be like.
I would
It
guess.
has to be between 0 and 1, right?
I think so. I'm just like. Yeah, I mean the rules of probability is it has to be between 0 and 1. Yeah. So I think it is just that 0.45. I mean, it already gives the proportion, the probability. I mean, it gives us the probability up above, right? So
it'd be 45%. Because it's all based on 100.
Well, we're not supposed to put things
in percentage, yeah. What is the probability that? Okay.
0.45. That has to
yeah, that's. I think it is, and then we have to find the next answer. Is we're trying to find out what's the probability they will not have type O blood, which.
That was the optional one.
Yeah, which is basically you take 1 minus the 0.45, right? 1 minus 0.45, which equals 0.55. And then you do 0.55 divided by Is it? I'm not really sure.
Okay, so going back to the Columbus thing,
Mm-hmm.
the probability that Columbus would not draw the chickpea. So the formula was there were 40 other men aboard, so that number would go on the top fraction.
Mm-hmm.
So it's 40 divided by 41 because there are 41 total.
Right.
That gives the percent. So in this case, would that mean that we would go? We would go 55. There are 55 other percentage possibilities, or would we go 3? Because there are 3 other types of blood that could be picked.
Yeah, that's the thing is we have to figure out what's the total population that we're talking about.
What is the probability?
Because in order to find the probability, you have to find the total population.
Well, then the total population would be the adding up all of the other
Mm-hmm.
people, right?
Which would be 55.
So let's just see what that would give us. So if we had 55 divided by, oh wait, it was 55.
Well, I would think it's just going to be 0.555. I mean, I don't think we have to divide it by anything.
Oh, right. Yeah, you're right.
Because it's like, you know, it looks like 0.45 will of the population have O-type blood.
Yeah, it would just be the opposite. Okay, I think I'm overthinking all of this now. So, round to 2 decimal places. There are only 2 decimal places. Oh.
Yeah, I don't know. Maybe there is another step. Maybe.
Let's go back to this. Let's just keep working.
That sounds like a good idea because I feel like I'm not understanding what they're wanting. I hate these trick questions.
Right now. Yeah.
Okay, Caroline Willis and her colleagues conducted a study in which dogs were trained to detect bladder cancer. The dogs were trained to lie down next to a specimen derived from a bladder cancer patient. Tango, one of the dogs, demonstrates the identification of a specimen. 7 bowls containing urine were lined up in a random order. 6 of the samples were from patients who did not have bladder cancer. 1 of the samples came from a person identified as a bladder cancer patient. Answer the following questions. If the dogs guess at random, what is the probability that they will correctly identify the dish containing the specimen from the bladder cancer patient?
Okay, so let's do a little table here. We have how many of them? 7 total?
Okay, let's see. Okay, so there's 7 bowls. 6
0.148 or 143.
6 did not have bladder cancer. So it's 1 out of 7 is the
yeah.
1 out of 7.
What is the probability? Oh, so this is just like the dice.
Yes. Yeah. So 1 divided by 7 is
0.143.
yes. Okay. I feel pretty good about this one. So 0.143 if you round to the 3 decimal places.
Okay. Wait, what was it again? 0.143?
0.143.
Okay.
In a combined total of 54 trials, the dogs correctly identified the specimen from the cancer patient 22 times. It is very unlikely that the dog would do this well by random chance alone. Which of the following statements is most appropriate? This provides strong evidence that the dogs can detect bladder cancer. There is little evidence that dogs can detect bladder cancer.
So if they guessed it from the patient, identified it 22 out of the 54, that's less than half.
Well, I'm going to go ahead and divide that. 22 divided by 54 equals, that's
0.40.
that's like 40.7% of the time.
So most appropriate, there's little evidence that dogs can detect the right strong evidence that
It says that it is very unlikely that the dog would do this well by random chance alone, so this provides this provides strong evidence that dogs can detect bladder cancer.
yeah, because
That's what I was going to say.
little evidence.
Yeah. Is that what you think, Phil?
Yeah, I was going to say almost if something's almost half, then it's got a pretty high chance.
Okay. Yeah, that's what I'm thinking, and they say right there that it's unlikely that they would do that well by random chance. So I think that's. I'm trying to remember the rules of statistics. Is like if it's greater than 5%, you can reject the null.
Yeah.
So.
It is. So.
Yeah.
Good.
Okay. So M&Ms are small chocolate candies. The M&Ms website previously indicated that in the United States, the distribution of the colors in a bag of plain M&Ms is given in the following table. 0.13, 0.14, 0.13, 0.24, 0.20, and for some reason green is scribbled out.
You have to figure that out. So, 0.1. That's going to be 16. So the green is 16.
So what are you doing? Are you
I just
dividing it by 1, 2, 3, 4. 1, 2, 3, 4, 5, 6.
First, I just figured out what the green portion for the green was. So if we reach into the bag, what is the property of drawing a red colored candy? So it'd be 0.13.
Yeah, I mean, that's what they're saying. It just seems too easy if they give the answer fair.
Okay, I want to look back at the...
And this was very similar to those first two questions. So if we can figure out this, then we can answer those first two questions.
I think it is easy. I mean, it's not like it's a hard topic to understand.
Mm-hmm.
I think they kind of gave us this one after the last couple of quizzes to help with our scores.
You think so?
I mean, the probability is your percent. It's how what out of what larger number are you going to get this, and that's exactly what the Columbus thing was. So.
Okay.
I mean, essentially, they're
so taking
to make
the
it
same,
really
so taking what and applying it to the Columbus. So the Columbus equation is, so there were 41 men on the ship, and there was one out of the 41 chickpeas, there was only one that was marked. So that's your equation, right? So in this scenario, it would be, you would take the red, and I think it's going to end up being the exact same, but just to double check, right? So you would take the red, the probability of the red, which is 0.13, divided by...
I think I'm going to figure out what the green is by subtracting these from 1.
The green should be 0.16, yeah.
0.16? Okay.
Yeah, divided by...
Yeah.
Yeah, it has to be 13. Because if you were to taking that same same equation that they used for the Columbus thing,
yeah,
and punch in just the numbers for this thing, it would be, you would do 0.13 divided by 1, because if you add them all up, you know, which is 0.13.
Okay.
So it's got to be it has to be just...
So they're just trying to be so easy that it's tricky. Okay. So the green is 0.16.
Yeah.
And then the probability it's not green is 1 minus...
That'd be 84, right?
0.84.
It's just the opposite, right?
Yes.
Yeah.
Okay.
I hope that's right. We're going to get a big old fat F.
Before we get it, I want to just, or before we submit it, I want to just look at the, you know how at the individual preparation they have specific problems? Tutorials or whatever?
Yeah.
I just want to double check that.
Okay.
Just to make sure I'm not missing something so simple.
Okay.
Okay. Scores.
So this is the ACT scores the students admitted to a medium-sized public university in the western United States were taken from capex.com. The following summary statistics were calculated. 24, anyways, it gives the chart. Used information from the public university to answer the following questions. Half of the observations are less than or equal to what number? Oh, okay.
I want to, just a second. Half of the observations were less than 30. So the median would be the half, right?
Mm-hmm.
So it seems like 24, right?
That's what I'm thinking.
Because, or would it be 24.3? Which one is exactly the mean? Is the mean?
The mean is the average.
Oh,
and
that's right.
The median is the number that's in the middle.
So it's got to be that one then.
Mm-hmm. Based on the information on the table above, the top 25% of the students scored above what number?
So that'd be 22, right? Because that's the first quadrille.
Mm-hmm.
No, because it needs to be the 20.
27?
It's the top 20 of the students. So it's the highest.
Off 25.
Yeah, so it's quartile 3, 27?
Yeah.
The quartile 3 or the maximum?
The top, so the third quadrille is the 75 percentile and up. So it would have to be
27.
Mm-hmm. says, which of the following statements is not one of the 3 rules of probability? It's number 3 because there's no negatives in probability.
Yeah.
Yeah.
And then the last one is a clue to some. The probability that an outcome will not occur is 1 minus the probability that it will occur. So I think we did those ones right.
Yeah, that's the last rule. Yeah, that's right.
And that is kind of like a hint on some of the other ones that we did, which were the opposite. So, and I think we did those right. But we just got to figure out if we're doing like 1 and 2 and then those.
Yeah, I'm pulling up right now the video tutorials and just to see if they have one.
I'm going to just skim through the book again, too. I don't know that we've gotten into any deeper of this probability to kind of factor it out even more deeply. So if they give you the proportion, or which is the probability, I mean, I think the proportion and the probability should be the same thing, right? If it adds up to 1.
What I'm thinking.
That's a good question. Does that mean that the proportion and the probability are always the same? It definitely wasn't spelled out that way.
Mm-hmm.
But it seems like, yeah, that is what it is.
I'm gonna Google that really quick and just ask.
Okay, this is going to be loud for a minute so I can hear it.
That's okay.
Here's the lesson.
What is the probability that you roll a 5? What is the probability that you roll a 6? Roll a 3? What is the probability that you roll 1, 2, 3, 4, 5, or 6? What is the probability that you roll 1? Or every time you're going to roll one of them. Add up all of them. Last one. I'm going to also, a quick example here. We have, what is the probability of rolling Sonic was 1/6. However, you can't predict the die. Predict which number will come, whether it's 1 or 4. Question 4.
Okay. Okay, maybe it's on this one. Okay, in the homework they do the M&M one, which is a little more, which would be a little bit more like the 2 questions that we're wondering about.
Okay.
Because it's not it's not like the dice where it's proportionate. You know, you have one. Okay, so let me see what he says on this. Okay.
So here's another example. Number of girls with 3. What's the probability of hitting girls? So for instance, here's another. Here's the probability. Based on the rules of probability.
Okay, so I think we did it right because he was talking about the probability of getting something is the, yeah, we did it right. What is the probability of will not have, and it's the opposite, so we did it right.
You think so?
Yeah, so if you click on to if you go back to the individual preparation, click on lesson 4. The following link complements the reading, and it's the one that's labeled lesson 4.
Okay. It's which one?
The one right under the action. It says lesson 4.
Okay. Hold on just a second. I'm getting into another window.
Okay.
To find it. This is map 21. Okay.
And then click on to the heads and tails.
This is under lesson 4, and then under what?
Okay, so you go under the individual preparation, right?
Okay.
And then it has the step 1, 2, 3, 4.
Uh-huh.
And right in between the step 2 and 3, there's a link for a lesson 4.
Uh-huh.
Click onto that.
Okay.
And then on your far right-hand side, click on the head and tail.
Okay.
And I'm going to play that. So I don't know if you guys will be able to hear it, but.
That's 0 heads, and the probability that's 25%. 1 head. Heads. Some of you a little bit on this, but it's not a problem. However, the probability of getting head.
We can skip that part. Are you guys? Can you guys hear this, or are you?
Yeah, I think I'm hearing my own. Mm-hmm.
Well.
Mm-hmm. Mm-hmm.
What's the probability
So the part that you guys, no, we're just double checking is the M&M example that you.
Yes, it's the same as ours.
Exact same, yeah, and it's the same for the one above the first question.
Okay.
The blood type or whatever.
Mm-hmm.
did it right.
I think we did too.
So the only thing is, our rounding is the right place.
Here, let me get out of this.
Okay.
Okay, so I can hear you again. Sorry about that. Okay.
And then just double checking our rounding. I mean, they only give us 2 decimal places, so it's already rounded. That's correct.
Okay. Is everybody good with submitting it then? Should we try it?
Yeah. So we ended up with M&Ms. We ended up with 13 for the red, right? 16 or 0.16 for green, and then not green would be 0.84.
Let me see. 0.13, 0.16, and 0.84. Is that right?
Yep.
And then for the first 2 questions, same type of thing, 0.45, and then probability it's not is 0.55.
Yeah.
Yep. All right, let's try it. Hopefully we don't funk it out.
Oh, if not, I have to just chuck it up. Oh, good, 100%. Yay, we did it right.
Good.
That should help our grade.
Yay.
I didn't worry about that, but
No. I think I'm glad Phil's in our group because he's kind of our calm and we're like the I don't know. But after last week, it kind of made me freak out. Like I'm like they're putting trick questions in here. I don't know.
Yeah.
So okay.
I caught that 25%. I had missed that was the upper 25% and not the lower 20. So I'm glad I caught that too.
I'm glad too. Hopefully I'll do as well on my individual homework quiz. When it's just me to kind of sit there and figure it out, I'm going to be like, I don't know. But
oh, we'll do good.
I suggest doing the work in between because last week I already started the homework on accident because I thought it was the wrong one.
Oh, okay.
So I had to just kind of go with it. But
yeah,
it was all right.
Well, what we can do too. Oh, that's right. So you had to finish it. What I think I might try today too is wait to do the homework until after I hear the class meeting with our professor.
Yeah.
And just in case because he'll probably go over all of this stuff again.
Yeah. What time does he meet today? It's
like 12:30, but I can't go to the live one, but he posts it immediately.
He does, yeah.
So we'd be able to listen to it tomorrow morning or later.
Okay, sounds good.
Okay, well, I guess other than that, we'll just see you guys on Thursday.
Sounds good. All right. Have a good one, guys.
You too. Bye-bye.
Bye-bye.